make the best of it. Otherwise, I have my wingman Philip here. He's ready to jump in if needed. So let's see. How does it work? All right. So yeah, I'll start by briefly introducing myself. I'm the new CSO, Chief Strategy Officer of the Qtum Foundation. It started off with a computer science background. I have a master's in cryptography and computer science, also a bachelor in finance. Started off at Consensus Ventures. After that, joined the Qtum and been with Qtum for approximately 4 years. Right. Let's see here. Yeah, so it all started off in 2016 by our co-founders, Jordan, Neil, and Patrick. We had our ICO in May of 2017. We're actually one of the largest ICOs after Ethereum, raising $15 million. I know that's not a lot of for you guys right now, but we were the first large after Ethereum, and we would like to say we started the ICO boom back then. And yeah, we got everything in Ethereum and Bitcoin and Qtum, which has exploded since. So our treasury is still intact. Yeah. All right, so I would like to start to talk about proof of stake algorithms. So this is actually one of my specialties since I wrote a master's thesis on it, and I started it a long time ago, and it took a while to finish it since I had to update it all the time. There wasn't a lot of documentation, so I actually wrote some of the documentations that's out there. So yeah, I will share my thesis later because it's could be good if you want to understand proof of stake. So I will start by delegated proof of stake. So the proof of stake algorithms can be divided into two different categories. It's pure proof of stake and delegated proof of stake. So a lot of the top crypto projects right now have delegated proof of stake. And the delegated proof of stake essentially means that there are a small number of so-called block producers. These are servers that require high demand. They have high demand on bandwidth, but also on computing power in order to push out a lot of transactions. And the most of the large projects out there, they have like 20, 30, 40 nodes doing this, pushing out all the transactions. So what does this mean then? Yeah, it means that they have a very high throughput, and which can be really good for DeFi. But this is actually a trade-off between decentralization versus throughput. So these projects, it's like more or less what you value. So I would say they're compromising the decentralization perspective for the throughput, and I think it's all. I'm not like talking down on delegated proof of stake. I think it's very good as well. It's only different applications. So for example, high frequency trading can be good. This is what we call scaling on layer one. So for high frequency trading, for example, it could be very good. We're going in another direction. We're going in the direction of pure proof of stake. So as I said, Qtum's proof of stake model is a pure proof of stake. So it's actually a algorithm mimicking the proof of work from Bitcoin. So Qtum originally is it's a fork of Bitcoin, but we added the proof of stake on top of it. So in Bitcoin, you can see if you visualize the hash puzzle or the consensus mechanism as a lottery, each each lottery, each piece of the lottery is made up of the computing power in Bitcoin. However, in the proof of stake, it's made up in the proof of stake, in our proof of stake, it's made up of the UTXOs, meaning the quantum staked. So the more computing power you have in Bitcoin, the higher chance you have to append a block to the blockchain. And the more quantum you have, the higher chance you have to append a block in quantum. And one thing we really want to emphasize here is our low entry barrier. So with the smallest amount of quantum, which is 1 Satoshi, we call it the same as in Bitcoin. 1 Satoshi of quantum is enough to be able to stake and the Raspberry Pi, which is not really true, which I'll tell you about. But so in a lot of other protocols, you need to delegate to someone else, or you need to have a quite significant amount of the native token in order to participate in the staking and validation process. For us, it's really important that anyone owning some portion of the coin should be able to participate and validate the blockchain, and therefore there is virtually no threshold. And with the Raspberry Pi, that's not really true, because we had recently had a hard fork. We introduced offline staking compatibility. So that means it's users that doesn't have like a Raspberry Pi or a computer that can run a full node to validate every transaction on the blockchain, they can also stake. So they delegate their vote or their stake to a super staker node, which in turn stake for them for a fee, and the fee is set by the super staker. So it's supply and demand, I guess. Also, with the latest hard fork, we introduced a 32-second block time, meaning we are one of the fastest UTXO blockchains in terms of throughput. But as you can see here, even with the 32-second block time, we don't really come up to the throughput that other delegated proof of stake chains has. So here also it is a throughput of decentralization versus throughput, and here on our project we think we shows that the decentralization perspective is more important for us. So we're actually building from the bottom up. We're building as the internet, layer for layer. So we're not totally scaling on layer 1, but we're working on layer 2 scaling solutions as CK swap, CK snarks, and such. All right, so here you can see some of the Qtum's ecological footprints. In the recent days, there's been a lot of talk about Bitcoins and the proof of work footprint. So actually, for full nodes, it's pretty like low cost to run a full node. As I said before, you could run a full node on a Raspberry Pi. You could also run it on a cloud VPS on 100 watts. So it's totally up to you. I would recommend not running a too computing heavy computer, since it isn't needed. Anyways, so the current quantum nodes are 1,300. Quantum power consumption is 78 kilowatts, while as Bitcoin power consumption estimates to 129 terawatts, Ethereum 50.6 terawatts. So I don't really have the numbers here, but also these are two different consensus algorithms. So like we're only running full nodes, they're running full nodes and miners. So the miners are included in their energy consumption as well. But I think the comparison are on the, yeah, exactly. So yeah, so for the Dubai region, the power consumption was 22 terawatts, which is, I think it was like a fourth or a fifth of the Bitcoin consuming. Quantum uses less than a millionth of the power of the consumption of Dubai. Ethereum uses more than double the power of the consumption of Dubai. And yeah, here it is. And Bitcoin uses 6 times the power of the consumption of Dubai. And that's even like taking into account the full nodes. If we standardize our full nodes to have the same transaction capacity, because right now we don't have as much transactions as Bitcoin and Ethereum has, and it wouldn't be a fair comparison if we didn't standardize for that transaction amount. So even with that in mind, we are really consuming a lot of less energy. All right, so coming to our DeFi and NFT systems. So we know we're lagging a bit behind on the DeFi and NFTs. We've been pushing it for a couple of months now. One of the reasons we're lagging behind is because we're based on the UTXO model. So we're fully updated with the latest Bitcoin version. So we're using the Bitcoin UTXO for the security purposes, and also always updated with the latest Bitcoin version, which is, we're one of the only projects that are that. But we're also trying to keep up with the latest EVM. With that in mind, we're not an Ethereum fork, so we can't really utilize all of the cool Ethereum toolkit, money Legos, and stuff like that. But I will come to that. So first up for our DeFi ecosystem is SheSwap. It's the first DEX and AMM on Qtum, and I'm hearing they're planning to build out more functionalities. Next one is Janus. So Janus is an RPC adapter, which can get quite technical. It essentially just means that it's a translator for Ethereum toolkit, Ethereum dApps, Ethereum money Legos, to be able to plug it into Janus and like port it directly to Qtum very easily. So that will make it easy for all of you cool guys with cool projects to onboard to Qtum. It's in alpha stage right now. We have some slight hiccups with it, but I think it will be done in a month or so. It's actually fully working right now. Just some small minor details we need to fix. Also, we have Chinese RMB stablecoin Qcash. Had it for a while. I think it's the only Chinese stablecoin actually. Also, we have upcoming NFT functionality, which isn't really true because we already have NFT functionality and we have had it for a long time. But we recently introduced on the Qtum web wallet functionality to mint and also send NFTs on Qtum. Also have another project building NFT functionalities as well. Also, we have an upcoming USD stablecoin. So yeah, we think we're a great platform to build environmentally friendly NFT platforms and DeFi money Legos. And yeah, I would like to thank Agora for the chance to be here. And I think Dubai is really pushing for environmentally friendly solutions. So I think this is a great place to push out our message. And we really want to incentivize you to build your project on the Qtum ecosystem. So with that, we have two different things. We have the Qtum DeFi grant, which is essentially we're giving out money to any project that we will have like are technically solid to build on the Qtum ecosystem. So there's no strings attached there. But we also have the Quantum Ventures, which is our own venture right now. We allocated $10 million for it. We're probably going to allocate 10 million more, possibly even going to take in some other limited partners for it. With the Quantum Ventures, we love to see quantum projects as well, of course, but we're not limited to quantum projects. We're blockchain agnostic, and we love to talk to any project out there, centralized or decentralized. And yeah, that was it for me. Thanks for the opportunity to speak here.